Hello, everyone, and thanks for being here. My name is Yevhen, and I am an Android engineer at justeattakeaway.com. Today, we're going to dive into the practical ways of integrating Android Kotlin code with Unity and similarly embedding Unity projects within Android. We will discuss the subtleties of these integrations and also motivation behind these integrations. My personal experience of working with Unity wasn't something I initially sought after. At the very beginning of 2020, when I was preparing for a new chapter of my life in Germany, the universe decided to throw an unexpected twist in my story. The pandemic took the world by storm, unleashing turmoil on lives and economies alike. Many, like myself, obviously found themselves grounded and forced to rethink their plans. This is when an opportunity of working on an Android Unity project destined to serve as an Android Unity project presented itself, and I keenly accepted the challenge. When I first encountered C#, which Unity developers use, it felt remarkably similar to Java. The integration between Android and Unity was fresh to me and unexplored territory. I saw it as an opportunity to grow and to broaden my horizons in programming. So it was an adventure I was keen to undertake, and that journey brings me here today. So what's in the air and why might Unity be a cool tool for Android developers? So let's explore that together, shall we? Android development for Unity remains to be an underexplored territory. While C# Unity developers excel in their domains, they often find themselves unfamiliar with many Android-specific nuances. Think about the many updates of background limits, dose mode, scope storage, and runtime permission, coupled with their frequent updates and other various alterations. Even regular Android developers can sometimes get a bit lost with all these changes. When you are a Unity developer working across numerous platforms like iOS, Android, WebGL, and a variety of desktop systems, keeping up with every update can be challenging. Importantly, Unity does not support many functionalities out of the box, prompting developers to create their own solution or rely on a numerous ready-to-use solutions to effectively bridge the gap and work through the challenges presented. Therefore, if you are an Android developer familiar with Unity, you are in a unique position. This offers a distinct advantage, enabling you to stand amongst the fellow Android developers, especially in times of economic uncertainty and AI's ever-increasing prevalence in the industry. Unity is a powerhouse in gaming world with a staggering 61% of developers using it. This dominance is reflected in its thriving marketplace for assets, plugins, and extensions. This ecosystem presents a golden opportunity for Android SDK developers and companies alike. They can tailor their Android-specific projects libraries so that Unity developers can purchase and integrate them as plugins into their Unity projects. Drawing from my own experience, I've devoted quite a bit of time in crafting such integrative solutions. Consider Unity not only a gaming engine, but a powerful instrument to boost up engagement. Fancy adding some Easter eggs into your app. Unity offers an easy and direct way to export your gaming project into Android Studio, paving the way for the hybrid Android development. This allows your app to seamlessly combine standard Android functionality with interactive 2D or 3D content. On top of that, Unity's Project Tiny emerges as a solution for crafting light, small size, but at the same time, highly efficient games with blazing startup time. This specialized feature is tailored to assist developers in producing projects that can potentially be bundled in sizes under 1 megabyte, depending on features they add, obviously. So if you're aiming for a Netflix-like gaming segment within your app, Unity's Project Tiny becomes an indispensable asset. Hybrid development isn't just about games and interactions. It also touches on topics of virtual reality and augmented reality technologies. Therefore, we as Android developers can significantly benefit from embedding Unity into our projects to bring these immersive experiences to life. If you're scratching your head over augmented reality is simply a technology that layers digital info like images, videos, and 3D models onto our real-world view. Think of AR as a digital overlay onto our everyday surroundings. You can see examples of the AR experiences on the slides currently presented. I've just intentionally made this slide a silly one. Looks exciting, don't it? The beauty of Unity is how much it simplifies the complexity of crafting augmented reality experiences with 2D and 3D overlay on it, but more on that soon. Right. Now I've spent a fair amount of time trying to convince you that Unity could be quite an interesting topic, even for regular Android developers fellows. I believe it's now time to gradually shift towards gaining more practical insights, rather than just talking about the theoretical aspects. To do so, we're going to start by exploring how an existing Android project can be adapted into the Unity environment, thereby introducing some functionality not available in the Unity core. For this purpose, we're going to take a well-respected project from the Android sphere and gently reshape it, so that it plays nicely with Unity despite its original, purely Android-focused intentions. After gaining those insights, we will dissect the subtleties of the C# and Kotlin interaction, exploring how these distinct languages manage to cooperate and the mechanics behind compiling C# in such a way that Android can comprehend its instructions. After grasping the inner dynamics between the platforms, our focus will shift to a prominent project from the Unity world, which we're going to merge, or Frankenstein, if you will, with a native Android project to aid functionality. Wrapping up, we will touch on the topic of AR and VR development with Unity. Both terms get wrapped up into one term, XR, in Unity slang. Shall we dive in? Earlier on, I spoke about blending Android with Unity, and we found that if looked at closely, C# looks quite a lot like Java. This similarity means that for seasoned Android developers, getting familiar with C# at least enough to bridge our Kotlin plugin with Unity should be a walk in a park. In Unity slang, an Android library is essentially called a plugin, bringing added functionality to the project. So how do we make that connection? First, we need to create a library module in our project. It can be either an Android library module or a pure Java module, depending on which type of functionality you want to expose to Unity. In my experience, the Android library is often the go-to. That's primarily because integrating Android-specific elements into your Unity project is more common, and .aar files, unlike .jar files, can bundle both code and Android resources, making the integration smoother. Our next move involves defining a Kotlin facade class to efficiently bridge Kotlin and C#. A facade, by definition, is an object that serves as a front-facing interface masking more complex underlying or structural code. So think of this as a friendly interface that Unity can easily talk to and utilize in order to use Android libraries functions. On the slide, you see a class named Android Unity Facade, and it features two main functions we want Unity to have access to. With them, using them triggers Android libraries encapsulated logic. So once our front-facing interface is configured and ready to be consumed, we will run the build command in Gradle and place the freshly assembled archive into Unity's to assets to plug into the Android folder. And no worries if Unity's interface looks unfamiliar for now. We'll explore it in more detail shortly during our upcoming live demo section. To utilize functions from our Android library, we will create a C# script, basically a class script in Unity terminology, to act as a bridge between the Android and Unity environments. This script will interact directly with our newly created Android Unity facade. The slide currently displayed introduces Android plugin caller script. This script extends a foundational class in Unity engine named MonoBehavior. With the call Android plugin method, we instantiate an Android Java object. Unity has engineered this class to provide a pathway for C# scripts to interact with Java object. And all we've got to do is merely pass a package name followed by the class name as its constructor arguments. Once the object has been instantiated, we can hit up its call method, passing name of our target function from our Kotlin facade as an argument. So if a specific argument needs to be passed to our Kotlin facade, we employ the same call method, adding the argument after the method name. An example of this can be seen on the current slide, where we are invoking Android Unity facade.call, summon coffee to desk method, and passing coffee type as an argument. Continuing with that thought, this call method can handle primitives, strings, Android Java class types, and even arrays of such or of primitives. If you find yourself needing to pass a custom C# model as an argument using Android Java classes call function, just serialize the C# object into a JSON string, then pass the string over and deserialize it back once it gets to the Kotlin side. To handle callbacks and give Unity a heads up about specific events happening on the Android side, we usually lean on Android Java proxy class. When we want to create our own callback, we simply extend this class, passing the target Kotlin interface path and class name as constructor argument, and define a callback method. In our scenario, we're calling this method alert_lamp_genius, which will be performing a little magic carpet adventure. Over on Android end, all that's needed is to create an alert_lamp_genius callback interface, which has a function, importantly, one that is named the same as that one on Unity's end. So just like in our previous example, we just pass our newly created callback as an argument to Android Java objects call function and summon alert_lamp_genius from Kotlin whenever it's needed. So once we've got our caller function ready, it's time to tackle the Android dependencies from our library, particularly those mentioned in Android library's Gradle file. This is when the external dependency manager for Unity plugin comes in handy. After manually listing our dependencies in the Android dependencies.xml file in Unity, the plugin takes over downloading and managing them. All right, now we're ready to compile an APK of our Unity project, which includes the integrated Android plugin. For this, we navigate to File, to Build Settings, and from there switch the platform to Android, since we're obviously building an Android, and set specific settings like the Unity project name, package name, minimum target API version, target processor architecture, and more. Finally, we'll close settings and hit the Build button. Moving forward with this newfound knowledge of plugins, we're ready to intertwine Android libraries with Unity. Let's turn this knowledge into action and have some fun by integrating a popular open source Android app with Unity, ensuring they play nicely together. Following that, we will dig deeper into the intricacies of how the Android Unity connection works at the more detailed level. All right, folks, let's get our hands dirty and mix some Android code into Unity. Here's a fun twist. To make things more interesting and also more challenging, we are converting one of those official Jetpack Compose samples into a library for use within Unity. We've opted for Google's Reply app for this purpose. First off, we will open the app in Android Studio to understand what to expect in terms of display once the integration is complete. In order to bridge the platforms, we have to bundle the app into an AAR archive and add it into the Unity project afterwards. This requires swapping application plugin with the library plugin in the app modules Gradle file. So now I navigate to libs versions terminal file and create a new entry there named Android library. I copy it here and insert here, and hit the sync button afterwards. Then I replace the application plugin with a newly added library one in the app level Gradle file, and comment out application ID, target version code, version name. Since Unity has not officially added support for Java 17 yet, the next thing I have to do is to modify the compile options block to target Java 11 instead of Java 17. Likewise, I will adjust Kotlin options block, setting JVM target to 11. After making the necessary modifications to the Gradle file, I proceed to the Android manifest file. There, remove the replies intent, launcher intent filter and manifest icon attributes from the application tag. Now, with the conversion to a library complete, I create a class titled reply facade and define a function named launch reply app from Unity within it. This function starts the main activity of reply from its body. At this point, we recognize the need to pass the context as an argument to this function. And when we switch to Unity, we will take care of this, of passing context into this function. But at this step, the last thing what we have to do with the reply project is execute Gradle's assemble task. And when the build is complete, so we need to drag this newly assembled AAR file. So here we locate it into Unity project, which I empty Unity project, which I already set up, and checking if all is fine. Yeah, it's there. In this Unity project, I create a new script called Android plugin caller. And in this script, I create a function called start Android plugin. So to facilitate this connection between reply app and C# Unity part, I capture the facade's package name and class name, and also facade's launch reply app from Unity function name as class level constants in C#. As the next step, I instantiate the previously discussed Android Java object class here and pass class name of our facade as its constructor argument. So it will launch the reply on Android end. The only hurdle is to pass context on the Android end. The two commented out lines here reference currently running activity, Android activity from C#. And we will be subsequently passing it as context argument into our call to reply facade. I will explain the details of this shortly. So next, I include call to this start Android plugin into start function, which is part of Unity lifecycle. This ensures that the function is invoked immediately upon the script's activation. I navigate back to Unity, and here establish connection between newly created script and arbitrary element from the hierarchy window. It's not dragging there. Yeah, it's here. So in this way, the reply is consistently initiated upon the launch of the Unity project. Recall our discussion about requirement to list all Android libraries for Unity. I've already taken care of this, and here you'll see all the dependencies from the reply app, like compose and other dependencies. Then I open File, Build Settings, no further adjustments needed, so I just push Build button and save reply app there. So while we're waiting, let's enjoy beholding these funny pictures, and I hope our experience with live demo won't end up like that. And here is our optimistic body, always chasing, never quite catching. And this guy whatever is happening here. So, whoa, yeah, we've done. And then I just installed the app. And open it in Android Studio. Running devices. Here you see Unity project. So upon launching, you see Unity's logo and background. The on-start callback of our script gets triggered, launching the reply app from within Unity. Ooh, success. Yeah. As promised earlier, let's try to understand how we managed to pass the context into our reply app from Unity using C#. You see that when a Unity-built APK runs on an Android device, it launches a special activity known Unity Player Activity. It kickstarts the Unity engine. The Unity engine itself is like the stage manager that makes sure everything Unity-related does its thing on an Android device. Now, the cool part is accessing the running Unity Player Activity isn't rocket science, because it's right there as a static reference in the Unity Player class. So with Unity's Android Java class, getting into it is just a piece of cake. And that's precisely what I do here. I invoke the getStatic method on Unity Player Android Java class, grab that static reference to the running Unity Player activity, and pass it over as a context argument to the launch reply app function. Now, we've taken a look at the interaction between C# and Android. So let's learn about how Unity builds Android APKs. So actually, Unity gathers everything that is needed, like project files, code, plugins, templates from your project to form a Gradle project. Based on the settings you made in Unity, certain values get adjusted in the Gradle and Android setup files like manifest. Unity's scripting backends play a pivotal role preparing our C# code for integration into the Android environment. And we will explore these backends in more details shortly. Next, with everything in place, Unity uses Gradle just standardly to finalize an Android build. And voila, our C# code is now perfectly assembled and ready for Android. But when we're talking about Android in Unity, it's crucial to understand C# distinctive compiling process. In the Unity ecosystem, a scripting backend refers to the system that compiles and executes C# code. Unity offers support for two scripting backends, Mono and ILCPP, intermediate language to C++. Just the Java code is compiled into bytecode to be executed by the JVM. C# is also compiled into a so-called intermediate language before it gets translated into machine code. Unity uses a fork of the Mono project. When assembling an Android app, C# code is translated into intermediate language bytecode, which is then embedded within the APK. Mono scripting backend employs just-in-time compilation, so it compiles code on demand at runtime, meaning this process happening dynamically as the app runs. Unity Android uses Mono built with Mono target older 32-bit devices. On top of that, this scripting backend introduces some performance overheads due to its reliance on just-in-time compilation, and also presents some certain security vulnerabilities. Given these considerations, we won't delve further into the scripting backend. Consequently, IL2CPP, the second and more recent scripting backend available for Android builds in Unity, which emphasizes ahead-of-time compilation. It translates the entire code into machine-readable format even before the program is run, kind of like translating the entire book before starting to read it. The advantage, once translated, the program can run swiftly without the need to pause and translate more code. The backend also addresses a reverse engineering vulnerability present in Mono. Both backends share a similar step. They begin by compiling C# scripts into Microsoft Intermediate language. However, IL2CPP goes a step further. After the initial compilation, it translates this intermediate language into C++ code, which is then further converted into native machine code. After gaining basic understanding about Unity's scripting backends, let's try to understand how the earlier mentioned Android Java class and Android Java object actually bridge C# and Kotlin, so that when the Unity's function is invoked, it triggers on our Kotlin code. The Android Java object and Android Java class are essentially higher level wrappers around the Java native interface. They're designed to make it easier for Unity developers to interact with Java Kotlin code without needing to dive deep into JNI details. Given the JNI's role as the intermediary in this intercommunication, excessive use of Android Java class and Android Java object can introduce performance overheads. Therefore, it's advisable to limit number of calls to these functions where possible. In the Mono backend, communication with the Java side of Android is mostly done through the mechanisms provided the Mono runtime itself, but it's also C++ code. In case of IL2CPP, JNI interfaces are handled by the C++ functions that it generates. Essentially, your C# code is first converted into an intermediate language, then to C++, and then the C++ code interfaces with Java through JNI. Having explored the depth of Unity's scripting backends, it's time to see them at play once more. Well, earlier we've integrated an Android project into Unity. Guess what's next? Now we're reversing the role and sneaking a Unity project directly into Android. For this purpose, we're going to explore an official Unity sample project called Boat Attack, developed and maintained by Unity Technologies. This project is a small snippet of a boat racing game, complete with raceable boats and an island environment. So let's get hands-on. I'm opening the earlier cloned Boat Attack project. And beginning its transformation into a library for Android Studio project. Here's how. I'm navigating to File, Build Settings, ensuring that the target platform is set to Android, and ticking the Export checkbox. Opening the player settings, and here you can see that I use IL2CPP as scripting backend for assembling this APK, this project. And important not to forget to select correct target architectures, so it's very important for assembling proper .so C++ libraries for the project. So I'm closing the settings and hit Export button here. This will initiate the export of Unity project into standard Android project, which is directly executable in Android Studio. But to spare your wait, I already done that, and I'll just open the project already exported. As you can observe, the exported project has two modules. The first one is Unity library for all Unity things, and launcher for launching it on a device. So if directly run this project on a device, it would display something like this. Obviously, performance on emulator is not as good as on a real device. So yeah, but it works. Not really at this point, but yeah, now. As the expectations for mobile application continue to expand, we're sometimes compelled to seek tools that provide capabilities beyond those of the standard toolkit. Traditionally, the Android environment has been perceived and utilized from the visual standpoint as a set of material design components. Each component is designed to fulfill its role within the prescribed boundaries of Android conventional rendering mechanisms. But what if there is a need to advance a product beyond the standard out-of-the-box experiences? But there may be a need to develop a marketplace for selling furniture and offer customers the distinctive opportunity to place their desired pieces of furniture virtually within their living spaces through augmented reality. We may aim to create pioneering products seamlessly integrating rich dimensional visualizations into design and architectural projects, enriching educational and training experiences by immersive digital spaces. How about adding a bit of fun and playful deviation, allowing users to engage in activities like Pokemon hunting and interacting with face filters? Clearly, creating all of these unique experiences isn't something you can do with use of just the standard toolkit. To pull off 2D or 3D experiences, Android developers often turn to OpenGL, Vulkan, or Google Sky libraries, while Google's AR Core Android SDK is often the go-to for augmented reality features. But when discussing the fusion of the earlier mentioned experiences, combining augmented reality with a rich visualization, such as virtual furniture placements, let me tell you, it comes with a fair degree of complexity. Relying purely, let's say, on OpenGL can be quite a tough undertaking unless you have a solid ground in it, and even then, that's only scratching the surface. At the same time, Unity offers a decidedly superior and notably more straightforward environment for developing rich and interactive graphical applications. It neatly encapsulates many complexities and intricacies, enabling developers to focus on delivering complete user experiences without being burdened by the underlying technical challenges. Moreover, it allows for the development of cross-platform solutions, making your life a whole lot easier. To be clear, I'm not advocating for abandoning all native approaches in favor of exclusively adopting Unity. Ultimately, the choice banks on various factors, including specific use cases, the team's expertise, team size, performance requirements, and indeed, how much time you're willing to dedicate to the project. In discussing all of this, it's also important to remember a simple truth. What starts as something unique often becomes a trend over time. It's a cycle we've all witnessed repeatedly in our lives. Therefore, with increasing integration of augmented reality and virtual reality in mobile apps, it's now clear that Unity skills can position Android developers at the forefront of emerging technology trends. Friends and fellow developers, whoa, what a journey we've had today, diving deep into the confluence of Android, Kotlin, and Unity. If this harmonious blend captured your attention, I warmly invite you to read more information through these links on the slide. Big thanks for hanging out with me today, and wish you all a great rest of the evening. And if you want to talk or ask questions, you can catch me here. I'll be next to the stage. Thank you.